Good morning, guys. This is academic Wednesday, March 9th. We're learning about triangles. Before we hop into notes, please grab highlighters, markers, one or the other. You don't need both highlighters and markers, but a highlighter would be good, a pair of scissors, and maybe a piece of scratch paper or like an index card. We're going to use index cards in class, but grab those, and then we are going to start with a brain pop video, so pause if you need to and play when you're ready. Okay, here is that brain pop video. We're not going to watch the whole thing, but we're going to watch the first few minutes. This should all be review about triangles from elementary school. We just wanted to brush off some dust and look at this.
They're also acute.
Ooh, sorry, let me start that over.
Straight. You're nuts. Okay, time out. Dear Tim and Moby, I need to draw all the types of triangles. Can you help? From Liza. A triangle is any three-sided polygon. A triangle's three angles always add up to 180 degrees. We classify triangles by both their angles and by the lengths of their sides. Equilateral triangles have three sides of equal length. Since the sides are equal, the angles of an equilateral triangle all measure 60 degrees. Isosceles triangles have at least two sides that are the same length. At least two of the angles will be equal as well. Scalene triangles have three sides of different lengths. Every angle in a scalene triangle is different from every other angle. Correct. Equilateral, isosceles, and scalene triangles are all classified by comparing the lengths of their sides. Yep, I did say that we also classify triangles by comparing their angles. Let's take a look at those. Right triangles have one right angle that measures 90 degrees. The long side of a right triangle is called the hypotenuse, and the two sides that form the right angle are called the legs. Acute triangles have three acute angles. An acute angle is one that measures less than 90 degrees. Obtuse triangles have one obtuse angle. An obtuse angle is any angle that measures more than 90 degrees. So we've got 6 types of triangles. Those that are classified by comparing their sides, equilateral, isosceles, and scalene triangles, and those that are classified by comparing their angles, right, acute, and obtuse triangles.
All right, and that's where we're going to stop. Again, hopefully that was all refreshing to you, but if it's new, we'll go over it a little bit today. Okay, so starting back at the basics, I'm just talking about angles. An angle is formed by two rays. That's where you have like one point and then it has an end point and then a line that goes on forever. Those two rays have a common endpoint, and those are called the vertex. You've probably heard of vertex before. I always think of them as the pointy ends of the shapes. Okay, so in this picture right here, here's an example of a ray, or sorry, an angle. Right here, this is my vertex. And again, it's the common endpoint of these two rays. So you can label this as ray 1 and ray 2. Together, like how much they are open, this open piece right here, that's going to form our angle. All right, so there's different types of angles in that video. We saw like acute, right, obtuse, and we're going to actually talk about 2 other types of angles. The first one is complementary angles. Complementary angles are when two angles, their measures, 2 angles add up to 90 degrees exactly. Okay, so for example, if I had like this, I had 2 angles. I had this angle, let's call it angle A, and this one we can call angle B. Let's say that angle A is 40 degrees. Equals 40 degrees and angle B is 50 degrees. Now, because they're 2 measures, because 50 plus 40 is equal to 90, we could say that those two angles are complementary. Okay, again, if I'm going too fast at all, please pause and play so you can catch up. Okay, over here on the next one, we have supplementary angles. Supplementary angles are two angles that add up to, this one is 180 degrees. And if you know 180, that means they make one straight line when you put the two angles together. Okay, so for example, let me sort of make it skinnier. Okay, so for example, they add up to 180. So it could be two angles that look like this. It could be this really big one here and then this smaller one right here. It could be, let's say, like 140 degrees and then 40 degrees. Because 140 plus 40 equals 180, we could say that those two angles are supplementary. Okay, of course I have a cute little way, because they sort of sound similar, complementary, supplementary. A cute little way to remember it is this. So complementary starts with the letter C. Supplementary starts with the letter S. I'm going to do some magic and get excited. Already? Okay, complementary, again, they add up to 90. Wow, look at that. Supplementary add up to 180. Wow. I know, so cheesy. So that's cute little ways to remember those types of things. So let's look at a few examples. Okay, read those, see if you can figure it out. Pause and play once you've tried them out. Okay, if angle A is complementary to angle B and angle B is 23 degrees, what is the measure of angle A? Now again, complementary, see, I can turn that into that 90 degrees. Okay, I'm going to draw a picture to help me out. If angle A is complementary to angle B, that means they add up to 90 degrees together. And angle B is 23. What is the measure of angle A? Okay, 90 degrees. Oh, hey, 90 degrees, that means like it's a right angle. Okay, you remember that little square sometimes means 90 degrees. So it's saying that there's two angles. Let's call it angle A and angle B. And here it says angle B is 23 degrees. And we're trying to figure out what angle A is. I can also write an equation. I could say A plus 23 is equal to 90 because it says they're complementary. And hey, we've got ourselves an equation like we've been using for like forever now. Okay, I want to get A by itself, so I need to subtract 23. Whatever I do to one side, I do to the other. That cancels out. I'm left with A. And then let's do some math over here. 10 minus 3 gives me 7. 8 minus 2, 67. So angle A would be 67 degrees. That's an example. Again, if it's hard to visualize, just draw a picture. On this next one, oh, it doesn't say anything. It just says X. We need to find the value of X. Okay, I see that it's a long straight line. And whenever it's a line like that, that means that it's going to be 180 degrees, which is just another way of saying that they are supplementary. So I know that X plus 130 makes a straight line and makes 180 degrees. I need to solve for X. So I'm going to split my equation and I'm going to get X by itself. So to get rid of this plus 130, I subtract. X is equal to 50 degrees. All right, so that might be those two words, complementary, supplementary, might be new, but again, you can use those cute little doodads to help you out. Okay, now this next part hopefully is review. Again, if it's not, that's totally fine because we're going to talk about it and write it down. Okay, hopefully we know that an acute angle is anything that measures less than 90 degrees. You can draw this a variety of ways. It might look like this. Okay, we could say, oh, 67 degrees. That would be an acute angle. I could draw it like this. Well, yep, that's going to be acute. I know that because it's less than that right angle. Let's say it's, I don't know, 35 degrees. Oops, sorry. Okay, Both of those are acute. Right angles measure exactly 90 degrees. If there's anything more, anything less, it's not right. It has to be exactly 90 degrees. Okay? My lines aren't completely straight, but just pretend. A lot of times they use this box in the corner that shows 90 degrees. Oh, sometimes they won't even put the number. They'll just say that square, and that shows that it's 90 degrees. Okay, next one, obtuse. Obtuse angles measure it's more than a right angle, so it's more than 90 degrees, but it's less than a straight line. It's going to be less than 180 degrees. Okay, so I'll just do one example for this one. It's going to be a little bit wider, more open. So we can say that measures, let's say, 135. Okay, again, that's more than 90, but less than 180. Hopefully, we saw in that last example, a straight angle doesn't mean that it has to be completely horizontal or completely vertical, but it's a straight line, measures 180 degrees. And lastly, congruent. Hopefully, maybe not, you've seen this word before. Congruent means that they are the same. Okay, two angles with the same measures, congruent angles. You might see word problems where it says two congruent angles. So they don't have to be facing the same way, but they measure the same amounts. So they could be like facing like this. And if they both have the same measure, so let's say this one is 47 degrees, and if this one is 47 degrees, we could say that they are the same. They are congruent. Okay, just little helpful things that could help us in the future. So again, when we classify angles, we're looking at how much they measure. 90 degrees, more than, less than, all that stuff. Okay, next page. Okay, so going into triangles, just like in the brain pop video, we can classify our triangles. A triangle is a figure with 3 sides and 3 angles. We can classify it in 2 ways. We can classify it by their angles and then by their sides, which is what they showed us in the video. Now, a little fun fact. Every single triangle, so I'm going to put a little star up here, all triangles have at least, inequality word, at least 2 acute angles. Okay, what you're looking for is that third angle. Is that third angle another acute angle? Is that third angle a right, or is it obtuse? Every single triangle has at least 2 acute angles, but the other one is how we name it. I always like to pick 2 acute angles, cover those up, and then the one that's not covered up, that helps me name it. Okay, so in an acute triangle, there are 3 acute angles. If I covered up any 2 of the acute angles, that third one would be showing. Okay, so it could be that they are all, I don't know, 60 degrees, 60, 60, 60. Okay, those are all less than 100, all less than 90. If I covered these 2 guys up, this one would show. No matter how I look at it, they're all less than 90. In a right triangle, again, this angle right here is acute. This one right here is acute, but this third guy, that's what I'm looking at. It is a right angle, so it's going to be a right triangle. It only has 1 right angle, but that makes it a right triangle. The other 2 angles are acute. Okay? Again, in an obtuse triangle, there are 2 acute angles, so this one's acute, this one's acute, I see that, and then this third one, if its measure is more than 90, that is an obtuse angle. Those other 2 will always be acute, but that third one, whatever I'm not covering up, will be obtuse. Okay, this one's acute, 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 a cutie. It's a cutie little triangle. Okay, so that's how to do it by their angles, where we're just looking at those vertices, those corners. When I classify their sides, I'm looking at how long each side is, the lengths of the sides. Okay, so when we're looking at side lengths, we use these tick marks to help us out. Okay, these tick marks are used to show congruence. Okay, again, congruence means equal, the same length. So on this one over here, this triangle on the left side, I see that all of them have 2 tick marks. That means those 3 sides are the same as each other. On this middle one that says isosceles, this one and this one have the same amount of tick marks. Those are the same length. Now for a scaling, as we saw in the brain pop video, it means that none of the sides are the same length. So if I were to use tick marks, what you could see is that this guy has 1 tick mark, this one has 2, this one has 3, showing that since none of them have the same amount of tick marks, none of them are the same length. Again, on an equilateral triangle, it doesn't have to be that they all have 2 tick marks. It could be the 1, 1, and 1, showing that they all have the same length, or 2 tick marks like here. The amount of tick marks show congruency. Okay. So, an equilateral, the number of congruent sides, all 3 have the same amount of tick marks, so that means that all sides are the same. The number of congruent sides, there are 3 congruent sides. On this isosceles one, I see this guy and this guy are the same length, but this other guy, he even looks shorter. Okay, so that number of congruent sides, there's only 2 congruent sides. Lastly, scaling, since none of them match up the number of congruent sides, there are no congruent sides. You wouldn't really say 1 because there's just none. Okay, so of course I have another cute little way that maybe you already know. A way to remember the different words: equilateral, isosceles, and scaling, because they don't really sound like 3, 2, and 0. So something my 6th grade teacher taught me is that in the first letter of those names, equilateral has 1, 2, 3 parallel lines, 3 parallel lines, and that means 3 congruent sides. In isosceles, hey, boom, boom, it has 2 parallel. So that means 2 congruent. And then in S, there's nothing parallel to nothing. It's all wavy, curvy. So no parallel equals no congruence. Okay. Again, by sides is talking about the side lengths. They can have equal side lengths. And then for the angles, we're looking at the third angle. We cover up 2 of the acute angles, and then whatever the third side is. Okay? I always think, because you can name them in 2 different ways, it's like giving them a first name and a last name. One name is by angles, one name is by sides. Okay? So we're going to do a quick activity. If you're at home, I'll sort of walk through it. If you're in class, your teacher will walk you through this. So if you've already done this activity in school, just skip ahead. Okay? So if you're at home, what you need to do is cut out, you get that piece of scratch paper that hopefully you got, or an index card, and you just need to create a triangle with 3 lengths. Okay? Pause and play if you need. Once you get your triangle, you're going to highlight the little corners just like it did right here. Just make a little mark on each side. Make it big enough so just don't do the tiniest little dot on each side, but color each of the corners. Now don't make it big either. Okay. Next step. Once that is done, you're going to cut off the 3 vertices. Don't cut off, like if you cut, don't cut off right here. You want a little bit of white space. You see how the line has a little bit of white space with the colored corner? Make sure that you're cutting so that there's some white space on the end. Cut off all 3 corners. Okay? Now you're going to try and get all of those highlighted pieces and touch them, like here, I'll show you a picture so it makes a little bit of sense when I say this. You're going to try and get all the highlighted pieces to touch like this. Okay? Putting all the like highlighted corners together. And you want to talk about what you notice. Okay, so pause if you need to. Okay? Now, hopefully what you notice is that when you do this, it makes this straight line. Okay, no matter what your corners look like, when you put the three highlighted pieces together, it makes a straight line. Now, if yours doesn't, that probably means that you did the activity wrong. I'm sorry about that. But if you did it correct, no matter the triangle that you made, all three corners put together should make this straight line. Now, what does that mean? That means that this angle plus this angle, so this angle plus this angle plus this angle, they make a straight line. Okay? What that means is those three angles of any triangle, because some people have different ones, those three angles will always make a straight line. That means they will always equal 180. Okay? And that is a fun fact about triangles. No matter what triangle, any single triangle, whether it's isosceles, right, scalene, whatever kind of triangle, when you take those three corners every single time, the corners will add up to 180. Fun fact. Okay, so that's stated right here on this next page. The sum of the measures of the angles of any triangle is always going to be 180 degrees. Because we know this, we can write and solve equations. Okay, we love equations. It's really cool. Okay, so what they said is that the measure of angle x plus y plus z, no matter what, will equal 180. So let's solve for a few on our own. Okay, I see that this one's 38, 55. I need to figure out what x is. So the equation I could write, again, it can be in different orders, but I can say that 38 plus 55 plus x, this guy right here, should equal 180. Okay, now I'm going to solve for x. Because I want to make my life easier, and I need to get both of these guys, the 38 and the 55, off, I'm going to go ahead and add them first. 38 and 55. That way I only have to subtract once. I'm going to add those two together. 3, carry the 1, 93. So this is the same thing as 93 plus x is equal to 180. Now to get x by itself, all I need to do is subtract. I need to get 93 away and do the same thing on both sides to keep it equivalent. Okay, cancels out. I'm left with x. Let's do some math. So that becomes 10. That becomes 7. Oh, I need to borrow again. 17. 10 minus 3 is 7. 17 minus 9, that would give me 8. Ooh, okay, so that's 87 degrees. X is equal to 87 degrees. Take a quick second. What kind of triangle would that be? How would we classify it, like with angles and sides? I see that this one is acute, this one is acute, and 87, that's less than 90, so this is going to be an acute triangle. I bet a lot of y'all were like, oh, it's going to be 90. It looks exactly. You can't judge a book by its cover. It's very close to 87 and 90 were very close to each other, but this is actually an acute triangle. It would also be scalene, but I'm mainly looking at the angles. Okay, does my answer make sense? Yeah, I would say so. I would say yes, because angle looks close to because angle x looks about 90 degrees, and 87 I would say isn't too far off, and 87 is close. It's not exact, but it's close. Okay, so go ahead. I want you to try the next two. Pause and then play once you solve for x for both of those. Write your equation too. We're going to have that on a ticket coming up this week. Okay, pause and play. All right, for this one, your equation should be something like x plus 42 plus 51 equals 180. Okay, those three added up. I'm going to go ahead and add those two. X plus, that should give me 93. Hey, 93, we just did that. Okay, and then let's solve. Minus 93, minus 93. Cancels out. X is equal to, I bet if I subtract it the same as this one, I should get 87 degrees. And again, I would say yes, it still makes sense for the very same reason. All righty. Now looking at this one, I'm going to sort of predict. I see that this angle is already super big. It's obtuse. In fact, this is going to be an obtuse triangle because that one angle right there is obtuse. That means that 17 and this other guy, they both have to be acute. Okay, so I'm already predicting that it's going to be really small and it's going to be something less than 90. I would say even smaller than that, but super small. Okay, again, I can rewrite this in any order, but could say 17 plus x plus 141 is equal to 180. I'm going to go ahead and add these guys. Remember, because of properties, I can add these in any order. 141 plus 17, 8, 5, 1. I can say 158 plus x is equal to 180. Subtract 158. X is equal to 10, 7, 2, 2. X is equal to 22 degrees. So again, does that make sense? Yes, because I know it has to be acute. And it is. Good job. All right. Now, let's see. Let me pause real quick. All right. So this last little problem that we're going to do together before I let y'all be free, it's a bit of it's a word problem, and we're going to go together, and hopefully we're going to put pieces together and follow along. It's going to take a lot of information that we've been practicing and then putting it all together. We're going to go over the same question, sort of similar to it, a lot in the next few days. So if you don't get it now, hopefully in the next time that we go over it, you will see. Okay, so let's go for it. Let's dive right in. It says, an acute equilateral triangle can be divided in half with a segment from the vertex to the middle of the opposite side. So that's what they did. They said they divided this triangle in half with that little dotted line from the vertex right here to the middle of the opposite side. It wants to know what types of triangles are formed. What are the angle measures of the two new triangles? What? Okay, it wants me to name the type of the triangle, and the angles and all that stuff, but it didn't even give me any measurements. What? Okay, so let's think about this. Okay, let's go back. So it says that this whole thing, the solid line triangle, is an acute equilateral triangle. Acute equilateral. Okay, so what do we know about equilateral? I know that equilateral, that's when they're all the same. Equilateral triangle, that means that all the sides are the same. And if all of the sides are the same, that also means that all angles are the same. Okay, again, I'm going to go ahead and mark it. I know it's equilateral, so that means this side is the same as this side, is the same as this bottom side, before I do any of the cutting. Now, because all three sides are the same, that means that those angles are going to be the same too. That makes sense. If it's open the same amount, and like the angle is open the same amount, that means all the sides are the same amount. So what you could say is, okay, like this angle and this angle and this angle are all the same. I could use the same letter. If this is x, this should also be x, and this should also be x. All of them are the same measurements. So I could say that like x plus x plus x is equal to, triangles add up to 180. Okay? And I can, hey, I have a lot of x's. How many x's do I have? I have 3 x's is equal to 180. Now to solve for x, all I need to do is divide. I can divide by 3. That cancels out. I'm left with x is equal to 60. So hopefully, if all the angles are the same, all the sides are the same, all the angles are the same. So that means that each one of these is going to be 60 degrees. 60 degrees and 60 degrees. Huh. Okay. So all angles are the same. That's going to mean that they're all 60 degrees. Interesting. Now, again, we're going to come back to that, but just stay with me. So we got that the equilateral triangle can be divided in half with a segment from a vertex. So let me sort of split this. So they've split the triangle. Ooh, Miss Lytle. Let me try that one more time. That was a horrible drawing. Let me try that one more time. I can do it better this time. Ooh, you know what I can do? No, I'm going to try it freehand. Oh, no. No, we're not. This idol's going to make a line. Bam. 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 Close enough. Much better. Okay, so when I split, I just take off 1/2 of the angles. I'm sort of splitting the triangle and moving 1/2 to the side. So let's look and see what changed and what's the same. I see that this angle is exactly the same as it was before it. It hasn't been cut, it hasn't been split or anything like that. So I'm going to go ahead and label that this one is 60 degrees. Okay, back here it says that it was divided in half from the segment from the vertex to this point down here. So this angle got split right in half. So what's half of this 60 degrees right here? Half of that should be 30. Now I don't know anything about this angle right here, but I do have enough information to figure it out. I know that that top angle is 30 plus the second angle is 60 plus x should equal, those three angles should equal 180. 30 plus 60, that gives me 90 plus x equals 180. And then x by itself, 180 minus 90. Oh, that one should be 90. So this x value, I'm going to erase that. This should be 90. That says 90. Very cool. And the other half of the triangle, that should be the same because this one is still 60. This is the other half, 30. And this would be 90 as well. So let's see if we have enough information. It says what types of triangles are formed. So remember, we can give every triangle two names. We can classify it by its sides and by its angles. So let's look at its angles. I see one acute angle right here. I see another acute angle right here. Let's look at this third one. That third angle is 90 degrees. So that means it's a right triangle. Huh. Very cool. Got that. Okay, now by the sides, talking about side lengths. I don't know any of the side lengths, but we're going to talk about in a few days that if each angle, this one's 30, this one's 60, and this one's 90, if all three angles are going to be different, that means all sides are different. That means that this one's going to be one length, this is going to be another length, and this is going to be its own length as well. So that means it's going to be scalene. Now, that was definitely a spicy question, but hopefully that all makes sense. Okay, so each one of those would be a right scalene triangle. Again, that one's a lot spicier than what you should have on your homework and classwork today, but definitely go through these. Get a feel for it, check your answers on Canvas, and please come to tutorials if you need help. Thank you.